Okay, so this is the sixth and final class in our PowerShell for incident response with Mr. Mick Douglas at Better Safety Net on Twitter. We appreciate him for all of his hard work in doing the class, and so I'm going to just give a big plug here for the show. BreakSec podcast is available to you for free. You don't have to pay for it. These videos are free. You're probably watching these at some point in the future from this class. So please follow us on our Twitter at BreakSec, or you can follow me at Brian Break. We have an RSS feed. You can find all that in our Twitter bio. So I'm going to get started here. Take it away, Mick.
All right. Well, hey, everyone, and thank you so much for having me come aboard and do this. Even though this is the last one, by no means am I going to be hasta la vista and right off into the sunset, never to be seen again. In fact, I'll continue hanging out in the Slack channel for PowerShell. I've been having a blast there, and I hope to hang out and also come in from time to time to share what I've been finding and playing with. So, with regard to PowerShell, get your minds out of the gutter, you guys. So, got really good news for you. You can see all the content, get all the slides right here at InfoSec Innovations, and there's the reaction I was looking for. Yes, yes, we now have enough people to run Security 504 in Seattle. So, October 30th through November 4th. You'll want to be there. It's going to be a good time. I'll bring candy. We can have all kinds of scary good time. Last week was the solar eclipse. I brought the solar eclipse glasses for my students. I'll bring candy for you too. Yep. So there still are slots. Feel free to attend.
Yeah, and this is 27. That was 2017, by the way. So if you're watching this in the future after that time, sorry, you lose out. I've got my 504 badge right there, so I'm going to use it to crash the joint. So they won't look at dates.
Welcome to come in. We can work something with you, sir.
Sweet.
We'll get you in. So for the homework, again, we have another week of like a swing and a miss. Nobody brought in any homework. Nobody had any questions. So that either means that everybody's doing a great job and having fun and doesn't need help, or they're not doing it. So I don't know what to say. Reach out. You got my contact info. There were some interesting proof of concept things that people sent me for the file integrity monitoring, and that's cool. But I got absolutely zero interest on the workstation to workstation traffic challenge that I gave in the last session. That made me super sad. And so as a result, that is what we're going to be focusing on exclusively tonight. And it's a teaser of a script that I'm going to be releasing at my DerbyCon talk coming up in a few weeks. And the script that we're going to be going over is a tool called Sideswipe. So Sideswipe is an attempt to solve a pretty weird problem that I've noticed over the years. Most organizations are pretty good at detecting north-south traffic, that is, traffic that leaves a particular subnet. That's great. That's cool. The problem is when it comes to east-west. If an attacker stays within that subnet, they're able to do whatever they want and nobody detects it because, quite frankly, it's really hard to architect a network to see that. And so what I've got here is a script that will help you see what I'm doing and how I'm doing it, and what you can do within PowerShell, and it's really quite fascinating. So let's dive right in. All right, so what we're going to do is create a tool that will detect what sort of east-west traffic is taking place and record only that traffic. Now, what's weird is the more I looked into this, the harder it became. So what I'm going to do is break down some of the neater and more subtle features of Sideswipe, and you're going to get a pre-release view of it before it's out on the public GitHub repository. First of all, item number one, most packet capture tools have a very big problem in that they can consume too much hard drive space. And so Sideswipe, I made it so that it won't ever take up too much space. The maximum file size that you can ever record, unless you do a little bit of PowerShell hacking with the scripts that I've got, is 1 gigabyte of packet capture, or 1% of free disk space. And so what I'm going to do is I'm going to show you how we actually go about calculating that with some WMI objects here in a moment. So let's go over to our trusty prompt. What you can do is get WMI object, and then you can select the Win32 logical disk object. And you'll see that it shows the different drives, and it gives you the free space, the total size for the volume, etc., which is great. And so that's nifty, but we want to, like I said, we want to use the 1% of free space, or whichever is less. So that's actually not too difficult to do in PowerShell. The syntax is a little weird. Here's how it works. You're going to need to use this filter object. So if I go back to my WMI command, you can type in filter, and then you can type whatever you want. And in this case, I'm going to filter on C:, and now it's going to throw an error because demos. Let's try that. There we go. And now I'm only going to show the particular drive that I'm interested in. And if I want to then reference the free space of that, you can do something like this. Foo equals this, and now I can do foo dot free space, and I get the free space associated with that object. So that's kind of nifty. But what's even weirder is, check this out. If I divide this by 1 megabyte, it throws an error because of demo reasons. But here's the actual, let's see if I can, oops. Let's see if I can get this to work. So bar equals to foo. And now we can do bar divided by 1 megabyte. And I think I got to do it that way. And now you actually have in meg the size of this particular partition, which is cool. It's weird in that with PowerShell you can actually do this sort of division. Like if I wanted to see in gig, it does that. And then simply all you need to do then to make this a nice even number is make use of this math round function, and now we know the entire size of the disk, or at least we know the size of free space rather, and we have it in the megabytes, which is what we're going to need later on in this script. So that's step number 1. Step number 2. Now this one really threw me for several loops, and I thought this would be a much easier thing to do. There's 2 different API that WMI supports for interacting with network cards, because Windows, I guess, I don't know. The one that you need to use to see whether or not a network card is physically attached is Win32 network adapter, And the one that you need to use to get the actual IP address and subnet information is Win32 network adapter configuration. So don't know why. Took a little bit of Google searching or Bing searching to find the right stuff. By the way, if you are struggling for stuff in PowerShell and git-help isn't doing it for you, Bing actually has some really good hits to the TechNet, which kind of makes sense, but it's just Bing is one of those times that or PowerShell is one of those times that I do use Bing. So what I'm doing right here on this particular command, this is such a weird one, and I need to walk you through this a little bit. This getWMI object class network adapter, first of all, this is bizarre. Whoops. Let's clear this. If you just run this on your machine, now depending on how your machine is working, this is my normal teaching rig, and you'll see that when I hit this, there are just plenty of nicks all over the place. A lot of these are USB adapters that I've plugged in maybe once or twice and have never used again, and they just sit there forever. And you can actually see this device ID 25. There actually are a ton of them. When I do this, you can actually see that there are indeed 26 different network cards on my machine. And this was a huge problem for me initially because I didn't know like which ones I wanted to record and which ones I needed. So what I started doing was playing around with this, and I found that there's something very interesting, and that there was a membership object that wasn't tracked in this default output. Let me show you this. Get member. This is where that get member thing that I talked about way earlier in the class really comes to bear. There's a variety of different options in terms of adapter type, auto-sense availability, etc., etc. And you'll note that not many of these are actually shown in the defaults. So what I did was I did a little bit of searching around, and I found that there's, oh geez, where are we at? There we go. There's a net connection status, and here it is right here. This net connection status supports different variables. And this, one of the things, and this really kind of confused me. This is an integer that indicates what the status is of a particular NIC. And it can be 0, meaning it's not connected, 1, meaning that it's connecting, and 2, meaning that it is connected. So what you want to do, which is totally intuitive, not at all intuitive. What you're going to do is your filter connection status equals 2. And then when you hit enter, you get, in my case, only 3 different VM network adapters. Your mileage may vary. You might only get 1, but this is a lot better than seeing all 26 adapters. So using this filtering, you can, within WMI, you can like get a much more exacting count of what you're after and have more targeted results. Now I'm going to warn you, get member will get you only so far. And a lot of it is trial and error and a little bit of programmatic fuzzing around with the APIs. Because some of these have really scant documentation. And I'm saying that as a spoiler for something that's going to be happening later in our class session today, because I was really thrown for a loop at how bad some of the documentation gets in some areas of this. So now, I now have this. Let's go back to this. What I need to do is I want a listing of all the network cards. Now, network cards on your in your Windows environment all have a device ID, and that's just basically the number of the NIC. You know, nothing fancy. And this is kind of like an auto number that, at least from what I can tell, is unique to the different settings that WMI interacts with. Because I was trying to use the name object to interact with other WMI objects, and it's not consistent. Yay. This was a rough lab to set up. So now comes the real fun part. What we've got here is a command that will walk through each of the enabled network adapters, because we've already made our list of the network adapters that are active in here. And for each loops, in this case, we're going for each NIC, we're going to do some information gathering. And what we're going to do is make use of a slightly lesser used feature in WMI, or at least I don't see many people using this. Some folks probably are using this quite a great deal, but what we're going to do is we're going to pull the actual network adapters out. Whoops. And the way we're going to do that is like so. Now, demo fails. All right, let's try that again. And what we're going to be doing is pull from the Win32 network adapter configuration where the index equals, and we're really only going to care about my wireless adapter right here. So this device ID equals 1. Now, I realize that the keyword here is index, and that's because I don't know. Like, I think they want me to be drinking is all I can think of. When I hit that, you will see that we get the proper description in this case. But now I also have my IP address and the MAC address that's affiliated with my machine. So now what I'm going to do is, let's run this command again. And I'm going to pull the NIC config equal like that. And so now I have this object that contains this stuff, okay? Now, to reference these particular items, you can do NIC config dot IP, and you actually pull the IP address information, which I think is nice. So now with this, what we can do, oh, I think I see a question. No questions. All right. Keep the questions coming though, if anybody has them. What we're going to do now is we're going to do a little bit of math. Because now that we got the IP address and we also have the subnet, no, I'm sorry, that's not a MAC, it's an IPv4, an IPv6, you're correct. I'm so sorry. Thanks for fixing that. We can pull the MAC if we wanted, but we can get the IP subnet. So using this, now what we're going to do, by the way, thank you for correcting me on that. Now what we're going to do, and I realize this math is IPv4 specific. This is just proof of concept code right now. But what I'm doing is I am splitting apart the IPv4 space. And for the subnet, I am doing the math it takes to determine what is a particular CIDR range. Now, the cool bit about this is with this info, I can now determine what the CIDR is for the network traffic within that subnet. So let me walk you through that right now. To make this easier, okay, so now I've got this. And what I'm going to do is just copy paste this one-liner. And if all went well, that's looking pretty good. So what we're doing here is we're splitting up the subnet into the different octets. And then each octet, we're doing the math that allows us to do the subnetting math. And I don't want to get into that. We can if you get really bored. And then what we're going to do is we're going to split the IP address up. Let me do this copy a little bit better. We're going to take the IP address. Oh, geez. And now, if we did our math right, which is a copy-paste job, we now have the CIDR range for this. So, yay! Which means, big payoff, we now can write a packet capture rule. So, now that we have this, we can actually start generating our packet capture filter. Now, this is the thing that damn near killed me over the last couple days. So one thing I want to point out, if you haven't seen it yet already, please look at the tweet I sent out about the default filter rules that Microsoft provides. They're amazing, but unfortunately, I couldn't find a default rule that fit what we needed. So we're now going to spend the rest of the class working on this monstrosity, the set perf trace filter. So when I said thank you for posting that link, here, let me load that up for the benefit of the class who's going to be watching this. This library list here contains the built-in trace scenarios. So trace is the function that Microsoft has for providing packet captures. Now, there's one thing that really weirded me out about these Microsoft Analyzer trace sessions is that you can only have one going at a time, which no idea why that's the case. Meets your requirements, and you'll see that they actually do have some pretty lovely logics built into them. But unfortunately, I couldn't find one that meet the criteria for what I wanted to do. If you think about it, recording only local loopback is really quite weird. So what I did, not local loopback, the local internal subnet. So what I did was I read through these and started learning how the capture logics work, and started walking through a series of, here, let me show you the code that I've got here. Using the PF trace session. Now, the thing that PF trace session has that I'm a little unhappy with is they do have some info, but compared to some of the other ones, it's not been the greatest help. This one, I do have to say, has been helpful, though, is like walking through how these different elements work, including you can specify like different sources that you're looking for, and you can create some very complex logics. It's, you know, coming from an old time Unix guy that's used to Berkeley packet captures and Berkeley packet filter. It's not as nice and easy to use as that, but what you can do is make something that's really quite working. And what I'll do here is I'm actually going to, let's, boy, I hope I don't blow up the network on this, but we'll find out. Let's run this as is and see how this works. Right now I've got this in debug mode, so it should be visible, and that's something that we won't have on the production version. You can actually hide this. But what will happen is we actually are creating a packet capture with some pretty interesting rules. And what I want to do is walk you through some of the components of this. Now, this provider's here, right here. Is one of those providers. So you can play around with this and have a whole lot of fun with these elements. So I'm still not done doing analysis on which capture providers I want to use. I think this is the right one. If anybody's got any insight into these, I would love to hear them. Unfortunately, there's not a whole lot of documentation or people who are using these. And quite frankly, I understand why. So let me kill this packet capture off. And I want to walk you through a few things that I've done here. And yes, I know I'm not using PowerShell ICE. That's okay. I'm a Sublime guy. Now, what I like to do here is I want to show you how you make this filter string, because that was one of the first things that was a real kick in the teeth. So what I'm going to do is pause execution of this script as soon as it writes out the filter string. And what we've got here is this for each loop. This roughly translates to what this slide back here was. I've made a few tweaks to it since I made the slide deck. Before I post the slides, I will adjust them to match what I've got here. But what's interesting is now that I've got this, for each network card that is up and running, I can now create a filter that will allow me, because remember, I can only have one session running at a time. Yay. I have to put all my filter logics into one capture. And so what I'm doing is this. Let's run this. And you see that I'm catching all IPv address, IPv4 that hits this subnet, or this subnet. Now, I want to point something out. There's two pretty important things here that are not immediately apparent if you've not done this sort of capture work before. This is the two pipes like this would not work in this scenario, for instance. But if you wanted that, that's simply that, two ampersands. Now, the other thing here that was really non-intuitive, at least to me, was I'm used to saying things like source address, dest address, or S adder or D adder. That's not how they roll in Microsoft land. No, no, no. What they do is if you want it to be an IP address within a particular range, you put equal equal and then a CIDR range. I don't know why. That like really floored me. You can also, if you want, you could do this. Like 10.1.1, keeping with our internal. Like this. I've got too many IPs in there. Somebody should have said something. So you could do that. This would be a valid range too, but you know, it's easier if you've got the CIDR notation. So I went through the hoops. We're going to use CIDR notation, and it makes slightly easier rules to read. At least I think so. So that's how you go about building up this particular packet capture. This killed me. Yeah, so the question was, or is pipe, like that, and then and. I don't know if there's not. I would assume it's bang, bang, but I'd have to double check. So that's how that works. And once you've got that done, you can then go through the process of invoking the actual start of this process. Or hold on, let's comment these out. You know what? I totally am going to pay for this Sublime text. I will, with the fat loots that I make for doing this class. I actually think I have a paid version somewhere, but whatever. So now the next bits are this new perf trace sessions. Okay, so let's zoom in here a little bit and talk about this a moment. So we've got this mode circular, which that's basically just a rotating packet capture. So once the packet capture fills up, it's just going to be a buffer. And then this force is a very interesting flag. You'll find it on quite a few PowerShell commandlets. And what that will do is things like either cause hidden features to appear, or it can also force the overwrite of files, or force the different settings to take place without prompting. So like if it normally would prompt and say, hey, do you want to do this? It'll just go ahead and make that change. I would encourage you, just as a little bit of a warning, take a look whenever force is an option. You want to double check, because some PowerShell scripts, or I'm sorry, PowerShell commandlets make use of force in different ways. So for instance, get WMI, get WMI event will actually list only ones that are shown as public. But if you're running it as an administrator, you can do -force, and it will show any hidden Windows eventing objects, which I have seen bad guys use it as a way to hide what they're attempting to do. So be aware, force is very good, but it doesn't always act consistently, which, yay. Then we have our path. That's real simple. I'm basically just writing to a particular directory. And then we've got our total size as that 1 gigabyte or 1% of the free space, whichever is less. And then we save the capture on our stop. And by the way, the captures that these PEF traces are done, They're in a format that Microsoft has a tool that handles these. There are PowerShell scripts out there that can parse these as well. And depending on how you write them, in some cases, Wireshark can read them. The way that I'm doing it right now, I don't believe Wireshark can do natively, and that's a deliberate choice because it's my understanding that it's the fastest. There's a few weeks between now and DerbyCon where I'm going to be doing a whole lot of performance testing and see how this works and does it work fast enough for us. Okay, so the next little bit then is the message provider. Message providers are basically, I don't know like how to describe it. Let's even walk it back a little bit. Providers in PowerShell are sources of data. So for instance, in PowerShell, when I do something like cd hkey lm software, HKLM, the registry in terms of PowerShell is a provider. And so now whether I'm going to my D drive or the registry, those are providers. Likewise, there's providers that you can interact with in terms of performance monitors, network devices, etc. And in this case, we're listening to the Windows packet capture options. And then finally, what we do is we assign this our session to the trace that we set right here. And with that set, then we also set our filter, which is that depending on how many network cards you have, could be a fairly long list of captures to do. And then once you have that, then you now are capturing packets. And to show that, I have network capture here, and it just opens up with the message analyzer, and then you can do your analysis there. Should be popping up here. Yep. So now I've got my network packet. Now, in this case, I wasn't sending any internal network traffic, so there was nothing recorded. But on other ones, it was working. So I could change the logics, and we can catch that. But that's kind of how it works. And that's kind of the short of it. So now, are there any questions about this? I hope you guys see that this could be something very powerful and neat to have. The main thing that I want to start doing is to have folks running this script at least in a couple places in their network. It doesn't have to be on every machine, but for goodness sakes, 1%, just 1% of free disk space, I think you can afford that. Step away from a PowerShell Nmap. I don't know what you mean. Oh, like everybody's doing PowerShell Nmap implementations, and
yeah, I mean, you're going to scan east west. You can scan north south. At that point, it's just creating some kind of script up to look for various vulnerabilities at that point. So I mean,
yep.
Which you can already do fairly easily. So implementing this together would be fairly trivial, I'd imagine.
Yeah, well, not only that, see, the other thing that's going to be kind of fun with this is I actually hope to start using this as part of hunting in networks and deploy this on systems, weeks or months prior to me doing the engagement. And then that way I can see, which workstations are talking to one another. Because if you're in the same subnet, you typically aren't talking to the same machine in the same subnet. If you're all in the workstation one and the servers are in their server one, I would expect there would be all kinds of crazy, interesting stuff. Yeah, it is a form of PowerShell IDS, I guess. That's a pretty interesting way. I hadn't thought of it, Joel, like that. It's like a host-based network IDS of a way, which is, gosh, like I almost want to start. You know what we can do is we can start trolling the vendors and start calling this a user behavioral analytics host-based network IDS. That's what we got to do. So let's type that up. UBA host-based Oh, yes, it always needs more machine learning, host-based. Um, well, so toward that end, I've got actually some good non-trolling news about machine learning and AI and stuff like that. There are some people who are starting to port some of the libraries that are used in machine learning over into PowerShell. Now, I don't know how performant that code is or if it's something worth looking into, but there are some use cases of machine learning that don't suck. And for proof of this, you may want to take a look at, it was John Strand gave a talk at DerbyCon, I think it was 2 years ago, where they were using the fast Fourier transform analysis on packet captures to detect beaconing events. And that's a form of machine learning. Other than that, like it starts to get kind of thin. Like we've used Markov chains a little bit at Binary Defense for doing user analytics when we have very small data sets. So like I hate saying user behavior analysis, but I did. So anyway, you can use like Markov chains to do some baselining when you have a very thin data set. It's not perfect, but it's better than just kind of running with what you got, because you might not have enough for a really good trend. But other than that, it starts getting pretty thin. And don't get me started talking about AI. Just, it's sad. If you ever want to really troll a vendor hard when they start talking about AI, ask them whether it's strong AI or weak AI, and they'll be like, "Oh, that's good AI, and we'll get a sales engineer on the call, and they'll get that all squared away." And just hang up at that point. Strong, of course. Yeah, well, I hope not. Um, yeah, I don't want my machines dreaming of electronic sheep just yet. So that's kind of where I'm at with Project Sideswipe. And what we're going to, what I'm going to be doing is if you want, and if you are a member of this event, I'll have this up in a public GitHub or a private GitHub fairly soon. And if you want access to that private GitHub, shoot me an email. You have my contact info, or you can even just put stuff in the PowerShell Slack channel, and I will make it available, and we can jam on that prior to Derby. And you'll get full credit, of course, for any suggestions or improvements. I've already got a list of things that I want to start doing with it, including making things like, maybe you care only about specific protocols, or, excluding hosts or things like that. So I'm building those logics in now. And, but it seems to be working, and it's not as horrible as I would have expected, which I know sounds really like I'm not believing in myself, but I don't know. This is pretty experimental stuff right now. By the end of this week, it will be much, much more steady. Getting into perfmon and going to be setting up some counters with this to monitor how this performs, and be sure that I'm not causing too much memory or disk I/O. So that's kind of where we're at, and hopefully that explains how you can use PowerShell for some pretty interesting blue team stuff. Having this from an IR perspective in advance, full packet capture from within your internal network, that'd be great. Wish I got to have that up more. So, any questions? Kind of surprised that there's fewer questions than normal.
I think everybody's just shocked. That's some really good stuff. So this is just okay. So I don't say it's just PowerShell script, but um, so this is a blue team and a red team. This is like a purple team thing you could use because
Yeah. So red teamers. Well, so there's a couple catches. From a red team perspective, you're going to need administrative privileges. Creating these traces is something that requires admin. So there's that. The other thing, depending on the rules of engagement as a red teamer, I might be a little reluctant to make use of this because I'd be writing to disk, and writing to disk is a very risky thing to do. It's very noticeable. That said, blue teamers, um, when the red team is doing packet capture inside your environment, you're going to lose because they're going to know what normal traffics are. They're going to know expected protocols. It's going to be just a curb stomp. So this could be very, very handy from a pen tester side of things.
very nice. Yeah, I could also it's less noisy than Nmap. So this would be like one of those tools that you would use. You've got local admin on a box. You want to run it because it's what's on the box. If somebody notices Nmap's running on a box and the Nmap's not supposed to be on that box, then that could be a red flag. So it's not going to show up as much of a flag if somebody's just running PowerShell necessarily, unless you don't run a lot of PowerShell in your environment.
Right. I actually think, now that I think about it, there's a way I think that you can stream this data. Let me check that. There is, I forget which one of these. No, it's not this. There's one where you can actually specify to stream the packet capture, which is weird because basically you're saying grab this. You're making a limited mirror port. Now that might be a very handy red team type activity. In which case you could actually potentially, and I'm going to have to play around with this, you might be able to do relays. So that'll be something to play around with. But yes, Joel K totally hit the nail on the head. Passive versus Nmap. If you do active sending of packets down the network, you're going to get caught. Well, maybe not. A lot of environments can't detect an ARP sweep. But Nmap, you should get caught. Fingers crossed. But passive discovery is definitely for the win.
Very cool. Does anybody have any other thoughts or questions or suggestions? Any ways we can use this? Be naughty? Was there anything in the last 6 weeks that maybe you would want to go over again with Mick?
Or if there's something else that you'd like to have as like some bonus section off sometime in the future. I'm going to have to take a couple weeks off from this due to some, the Derby projects and a couple other things. But I would love to return to this. I really had a good time with this. Yeah, hey, Paul, take your time. You've got the video. You can watch it a couple times. I'll be posting the PowerShell commandlets that were in the deck here. Yeah, like I said, this one definitely I ramped up the difficulty because there were people who were complaining that we were going too easy on you. So I let you drink from the fire hose this week.
Yeah, and we can always come back later with a more difficult PowerShell class, so to speak.
Yeah. Yeah, definitely. I mean, like, if we want to go, like, there's some really dark and arcane type things that we can do and play with. So I'm not at all opposed to that.
Very cool.
Or if you find somebody else, I'd love to be an attendee.
Very nice. Okay. Well, so we'll continue the discussion inside of our Slack channel. So you can sign up for that at breaksec.signup.team. That's https breaksec.signup.team. Bunch of other stuff going on over there, so feel free to join us there. All right, well, I guess I'm going to stop recording now, and if you have any other thoughts or suggestions, hit up Better Safety Net on Twitter.
Before you stop, hey everyone, thanks for watching these videos. Breaking down security, thanks for making this possible. I really appreciated it. I had a hell of a good time. I hope you enjoyed this, and looking forward to participating with the show again at some capacity in the future.
Awesome. Thank you, Mick.